Okay, as yesterday we described, what about the power system dynamic, the whole subject, what we are intends to describe in the whole subject, what are the various topics in the power system dynamics, what are the outcomes we are expecting after going through this subject. This was described yesterday, and while describing, we told in the unit number 3, there is a automatic generation control, one chapter, another is the about the voltage control. So in this, as also we were describing that power system being the very large system, it is our challenge to maintain or to continuously in operation, to have the power system in operation is the challenge for the power engineers. At the same time, we want to operate the power system reliably and economically. But reliably, economically is not possible until and unless the power system exists. Means the existence depend upon the stability of the system. So economic operation is important, but more important on priority basis, if you see the stability and the maintaining the load and frequency as a constant is more important than the any other factor. That's why now question arises, which analysis is to be performed and when. So as far as economic analysis concerned, it is performed since the power system say it is running. After each 2 and 3 minutes, the economic analysis is done. If any system, any generator or the whole system is not working, operating economically, at that time load change is done. Means some of the generators variation in the load. Some of the generator may change their load, may share their load in such a way that total generation is equal to the demand plus losses. But at the same time, it should be economical. Means suppose one generator is generating 100 megawatt, another is generating 50 megawatt, but economically it is not okay to supply the demand. Then 100 may come to the 80 and 50 megawatt may be increased to the 70, so that total is equal to 150. This is done in the economic dispatch, where this operation is done after each 2 and 3 minutes. This analysis is done after each 2 and 3 minutes. But as far as atomic generation load frequency control is done, it is done instantaneously. At the moment say demand changes from 150 megawatt to 149 megawatt, or even a 0.1% or 0.01%, at the same time it affects our load and frequency. It affects our frequency and voltage. So we change the system in such a way so that frequency again remains constant. So it is our purpose is to maintain the frequency of the system instantaneously. At the same time, our intention is to maintain the voltage constant or within a specific range at all the buses of the power system instantaneously within the minimum time. So now with this intention, we will describe how to maintain. Now as a power engineer, our duty is to maintain this is the output what we expect. Means how we want to the frequency to be constant, but how it is done, this is the role of the power engineer. Similarly, we want to maintain the constant voltage, but how it is done, it is the role of the power engineer. Okay, are you getting the point? Yes, Mr. Jagveer, समझ आ रहा है?
Yes, sir.
Okay. So now, if you see, this is the formula for voltage regulation. Do you know this formula? Have you ever studied this formula? If you write the phasor diagram, say one generator, say here there is a one generator, and there is a transmission line with the reactance R plus JX impedance. Here there is a load. Then if you write the formula for voltage regulation, sending end voltage minus receiving end voltage dividing by receiving end voltage, then this formula comes. So Have you studied this formula? Say here it is Rx, current flowing is I, so IR plus JX is the voltage drop. IR plus JX cos phi, and this IR like this, and IX perpendicular to this. So IR, so IR cos phi plus IX Z sin phi. From that this formula comes. ये आपने पढ़ा हुआ formula, मितेश?
Yes, sir.
Eh?
Yes, sir.
Okay. So this is the formula for voltage regulation. And in the transmission lines, the resistance of the transmission line is small as compared to the reactance of the line. So you can say this will be small in comparison to X into this. Here it is a, actually this is not P, it is a Q. Here RP plus XQ. So this is because of R is small, this is less, and XQ. So finally this formula approximately comes to be XQ by VR. Means the voltage of the system, voltage regulation or voltage of the system of any bus, which voltage regulation is voltage drop. So voltage drop any bus depends upon how much reactive power it is drawing. So if the reactive power demand is more, then voltage of that bus might be low. So it means to maintain the constant, or you can say to maintain the reactive power demand is met by the reactive power supplied, and reactive power supplied is done, reactive power supply is done, or control is done from the excitation system. So excitation system is operate in such a way so that reactive power demand is equal to the reactive power reactive power generation should match with the reactive power demand. If it is not, means reactive power is more than the reactive power supplied, then voltage will go down. So similarly, another formula you might have studied, P is equal to E by X and delta. We also described this formula several times in the last class, in the last semester class, power system analysis class, that P is equal to EB by X sin delta, where E and B voltage is almost constant on all the buses, or we try to maintain the constant voltage. So power supplied depends upon the power angle. If the power demand changes, if power of any bus changes, then delta means power angle. Power angle may change. If the demand is more, so delta may increase. But delta may increase, it means what happens? In increasing power may cause the increasing delta, and d delta by dt is equal to, means if the delta is going to increase, then the frequency is going to decrease. So if the P increases, then the frequency may also affect, because change in delta affect the frequency. So if demand is more, then the frequency may go down. But from here we have seen the frequency is affected by this. But as a power engineer, it is a challenge for us to maintain this voltage constant of all the buses, to maintain the frequency of the supply available to the consumers, and the frequency is maintained, try to maintain at 50 Hz. Only variation is allowed is very less, plus minus 0.5 Hz. So, and similarly, voltage variation on the distribution side is allowed plus minus 10%. On the transmission side, it is allowed only 5%. So as a power engineer, we have to maintain the constant voltage, constant frequency. Now, as a challenge, now what is the role of AVR? What is the role of automatic load frequency loop? That we will see. AVR means automatic voltage regulator. Means this AVR control the voltage, and load frequency loop control the frequency. So this loop consists of two. Again, then we will describe what is the ALFC. It is consisting of the two loops, primary loop and the secondary loop, that we again described in detail. And you will see later that primary loop is primary loop is relatively faster than the secondary loop. So that now to understand that, now this unit, AVR unit, this AVR topic, what is AVR, how the voltage is controlled, what is the excitation system. That is a one complete chapter here. This is the one complete chapter. We will describe this in very much detail once this AGC is completed. So one chapter is about the AGC, another chapter is about the voltage control, that is the excitation control or AVR control. That we will describe later. First of all, we consider this chapter called the frequency control, that is the load frequency control. So just to understand the now question is from how the load frequency control is done, from where and what maintains the what factor is responsible for maintaining the frequency. We know now, you see this figure here, this is a generator. We know generator supply the electrical power. It is a generator, it supplies the electrical power. Electrical power is step up. Electric power is generated at some voltage level, maybe 11 kV to 33 kV. It can be generated at 12 kV. It can be generated, electric power may be generated at 13 kV. It may be generated upon 15 kV. It may be generated upon 28 kV. Any voltage level depending upon the technical infrastructure and available and technical concept availability of the various technology, the voltage level electric power is generated. This power is then step up with the help of transformer is given to the transmission lines. Now where on the transmission line the load is connected. So this power, this load, this electrical load, from there this energy is coming. This electrical load means electrical power. Electrical power is coming from the generator. From where this power will come, it will come from this turbine. Here it is a turbine, or you can say prime mover, where this is rotated. Here inside this turbine, here there is a rotor which rotates, and this rotor is being rotated with the help of this turbine. Then only the electrical power is generated. So how it is rotated? From where the energy will come? This energy, this turbine supply energy to this, and here it is in mechanical form. The energy is in the form of mechanical. This mechanical energy is converted to electrical energy with the help of this generator. Now from where this mechanical energy is coming to the turbine? Turbine में भी electrical energy कहाँ से आ रही है? This is coming from this fuel. We are giving the fuel to the turbine. That either fuel may be in the form of steam, it can be in the form of any other means thermal, nuclear, any type of fuel may be there, geothermal, or it can be hydro, or any type of fuel may be there. From this here, this energy is converted into mechanical energy, then mechanical energy again converted into the electrical energy. This electrical energy is fed by here. Now this electrical energy which you are getting, or electrical power you are getting, electrical energy per unit time is the electrical power. Similarly, so here the fuel energy entering, chemical fuel energy may be in the form of say chemical energy, entering per unit time is the power. So this power should be equal to this power plus losses. Losses may be throughout this system. There can be some losses. Say 20% losses are here, 5 or 10% losses are here, and say 1% or 2% losses are here. So finally you can say after all those losses we got this energy. So this input should be equal to the output plus losses. If we forget the losses, say then this input should be equal to output. Or you can say output means this is also losses is again, you can say you have to meet. So output plus losses should be equal to from here. Now this continuously, we have to maintain continuously input is equal to output plus losses. Otherwise, it is not possible if input is equal to not output. If you are not giving the input, how you can get the output? So this input is to be continuously supplied. And when you supply the input to this, it is first it is stored in the form of inertia of this turbine. Turbine will have some rotor inside this, some heavy prime mover inertia is there. So this is stored kinetic energy in the form of kinetic energy. It is stored here. It is also stored in the form of kinetic energy here. Then continuously this input energy is continuously, or this input power is continuously supplied to the output power. In addition to in the beginning, it stored the energy inside this. So, if now what do you think? If this input is say this is from here, if we measure in terms of power, say 100 megawatt power in the form of this is entered into this after storing, because in the beginning it stored the energy, and this 100 megawatt is equal to this 100 megawatt plus losses. Now, suddenly, if you increase from 100 megawatt to 110 megawatt, what will happen? So, Diksha, can you tell me what will happen if this is 100 megawatt fuel? Because you are not in a position to immediately change, because this input is fixed. It is a mechanical system involved. If you are not able to immediately change this input in tune with the output, then what will happen? Output is suddenly increased from 100 to 110 megawatt, and this fuel energy is again equivalent to the 100 megawatt. Then what will happen? Yes, who will tell?
सर फ्रीक्वेंसी इंक्रीज हो जाएगी.
Why? Input is less and output is
power
more.
correlated.
No, input is less, input is only 100, output is increased. Anybody else? हाँ मितेश. इनपुट इज हाँ बताओ. ये आपका 110 हो गया और input is equivalent to the 100 only. So what will happen? From where? Now question is from where this extra energy will come? ये जो आपकी एनर्जी है ये कहां से आएगी? क्योंकि यहां से तो 100 ही आ रही है और यहां आपने आउटपुट में 110 मेगावाट ड्रॉ कर लिया, तो ये कहां से आएगी पावर? यस जगबीर. मिस्टर हरप्रीत, आर यू लिसनिंग हरप्रीत? हाँ नहीं सुन पा रहे हैं. कार्तिके, मिस्टर कार्तिके, रोबिन ठाकुर, मिस्टर तनु नरवाल. No one is responding. What is the problem? Harpreet, are you listening me?
Yes, sir.
हाँ, तो आप रेस्पॉन्ड क्यों नहीं कर रहे? क्या पूछा था मैंने?
अभी साउंड आ रही है, पहले साउंड.
नहीं ये बहानेबाजी मत करिए आप. कार्तिके, आर यू लिसनिंग मी? कार्तिके, मोनू, मिस्टर मोनू.
यस सर.
हाँ क्या क्वेश्चन पूछा था मैंने?
सर एनर्जी इंक्रीज होगी या नहीं, मतलब इंक्रीज हो जाएगी सर एनर्जी वो पावर.
क्वेश्चन क्या पूछा था?
सर उसमें चेंज होगा तो उसमें क्या होगा सर?
ठीक से सुनो, जब क्वेश्चन ही नहीं समझ में आएगा तो आप आंसर कैसे दोगे? मिस्टर पवन. पवन.
यस सर.
हाँ क्या क्वेश्चन पूछा था? व्हाट वाज द क्वेश्चन? है नहीं मालूम? ऐसे बैठने से कोई मतलब नहीं है जब तक आप ध्यान से नहीं सुनते हैं. मिस्टर रजत.
यस सर.
हाँ क्या क्वेश्चन था?
सर वो एनर्जी चेंज का ही पूछ रहे थे आप, उसमें कितनी बढ़ जाएगी?
नहीं आप ध्यान से सुन नहीं रहे हैं. आप कैमरा स्टार्ट करके और इधर उधर भाग रहे हैं. रोबिन. हाँ बताओ, व्हाट वाज द क्वेश्चन? क्वेश्चन क्या था? अगर आप अभी ठीक से नहीं समझेंगे तो फिर आपको, ये इनिशियल स्टेज है, इसमें जो क्वेश्चन क्लिक कर गया तो आपको कंसेप्ट क्लियर होगा, अदरवाइज कंसेप्ट क्लियर नहीं होगा। क्वेश्चन ये था, फ्यूल इज इक्विवेलेंट टू द 100 मेगावाट and output is more than that, means it is 110 megawatt. From there this extra energy will come. ये कहाँ से आएगी एक्स्ट्रा एनर्जी जो आपने, सपोज यहाँ से, तो ये पावर इंजीनियर है, ये जनरेटिंग स्टेशन, आप समझो थर्मल पावर स्टेशन, आप फरीदाबाद में बैठे हुए हो, आप फरीदाबाद में मिस्टर रॉबिन बैठा हुआ है, इसने 100 मेगावाट के अकॉर्डिंगली इसमें फ्यूल एंटर कराया हुआ है। और डिस्ट्रीब्यूशन साइड पे यूएचवीपीएनएल में डिस्ट्रीब्यूशन साइड पे मिस्टर हरप्रीत बैठा हुआ है, इसने अलाउ कर दिया लोड 110 मेगावाट का। ठीक है, तो ये एक्स्ट्रा लोड कहां से आएगा? यूएचवीएनएल में इसका हरप्रीत का ड्यूटी लगा हुआ है, इसने 110 मेगावाट आउटपुट दे दिया, तो ये एक्स्ट्रा लोड कहां से आएगा, ये क्वेश्चन था। एक्स्ट्रा पावर कहां से आएगी? Anyway, now listen, this extra power will come from the stored kinetic energy of this inertia. इसमें जो इनर्सिया है उसमें से एक्स्ट्रा एनर्जी यहाँ से आ जाएगी, एक्स्ट्रा एनर्जी। तो इसमें जो काइनेटिक एनर्जी की, इधर से तो 100 मेगावाट ही आ रहा है, इसमें जो काइनेटिक एनर्जी स्टोर थी उससे काइनेटिक एनर्जी वाज इन द फॉर्म ऑफ हाफ आई ओमेगा स्क्वायर। आई इज द इनर्सिया मोमेंट ऑफ इनर्सिया, ओमेगा इज द एंगुलर स्पीड। तो उसमें से ये एनर्जी आके इसमें 110 मेगावाट दे दी। लेकिन ये 10 मेगावाट जो एक्स्ट्रा थी वो कितने समय तक यहाँ तक आ सकती है? काइनेटिक एनर्जी हाफ आई ओमेगा स्क्वायर और कुछ एनर्जी मल्टीप्लाइड बाई टाइम, कुछ टाइम में वो एनर्जी खत्म हो जाएगी। अब ये 100 मेगावाट मल्टीप्लाइड बाई सम टाइम विल बी एनर्जी, तो एनर्जी ऐसा कंज्यूम होगी। एनर्जी कंज्यूम होगी तो क्या होगा, इसकी हाफ आई ओमेगा स्क्वायर की जगह अब इसकी स्पीड कम रह जाएगी, आई ओमेगा माइनस ओमेगा डैश, स्पीड कम रह जाएगी, इतनी एनर्जी इसमें चली जाएगी। तो इसमें जब स्पीड कम रह गई, इसका मतलब क्या है, ओमेगा स्पीड कम रह गई तो इसकी फ्रीक्वेंसी डाउन हो जाएगी। ठीक है, तो ये फ्रीक्वेंसी हमारी डाउन हो जाएगी यहाँ पे। अब फ्रीक्वेंसी जब डाउन होगी तो यहाँ क्या होगा, दिस इज स्पीड सेंसर, इट सेंस द फ्रीक्वेंसी, इट सेंस द स्पीड। यहाँ पे इसने स्पीड, यहाँ इसका स्पीड सेंसर लगा हुआ है, इसने इसकी स्पीड को सेंस किया, या स्पीड गवर्नर लगा हुआ है, इसने स्पीड को सेंस किया। जब इसकी स्पीड नॉर्मल से 1500 आरपीएम से कम हो रही है, इसने सेंस करके इसको कह दिया, स्पीड गवर्नर को, स्पीड सेंसर ने स्पीड गवर्नर को कहा यू इंक्रीज दिस। स्पीड गवर्नर क्या कहेगा, एक सिग्नल देगा कि इसे हाइड्रोलिक एम्पलीफायर को, स्पीड गवर्नर क्या करेगा, हाइड्रोलिक एम्पलीफायर को सिग्नल देगा कि आप इसको, ये पावर एम्पलीफायर है, इसको ये कहेगा आप इसकी पावर बढ़ा दें। तो ये यहाँ से फिर 110 मेगावाट के अकॉर्डिंगली एनर्जी इसमें फ्यूल एंटर करना शुरू कर देगा। तो उस समय इनपुट और आउटपुट इक्वल हो गए। जैसे इनपुट आउटपुट इक्वल होंगे तो इन द मीन टाइम इस प्रोसेस में सपोज आपका 100 सेकंड लग गए या 20 सेकंड लग गए। ओके, इस प्रोसेस में आपका अगर 100 सेकंड लग गए या 50 सेकंड लग गए तो क्या हुआ, उस समय तक इसकी फ्रीक्वेंसी 50 से 48 जा चुकी है, और उस समय इनपुट इज इक्वल टू आउटपुट हो गया। तो इसका मतलब क्या हुआ, 48 फ्रीक्वेंसी पे ये हमारा सिस्टम फिर फिक्स हो जाएगा, 48 पे चलता रहेगा। ओके, ये हमारा 48 पे चलता रहेगा। अब ये 48 इसे मंजूर नहीं है, दैट्स व्हाई दिस इज कॉल्ड द प्राइमरी। ये देखिए प्राइमरी एएलएफसी, प्राइमरी ऑटोमेटिक लोड फ्रीक्वेंसी कंट्रोल। ये अपने आप इनपुट इक्वल टू आउटपुट तो कर दिया तो 110 मेगावाट के अकॉर्डिंगली, लेकिन ये फ्रीक्वेंसी मेंटेन नहीं कर पाया, फ्रीक्वेंसी इसमें 48 रह गई, क्योंकि इसका काम क्या था, इनपुट इज इक्वल टू आउटपुट करना। वो बाय दैट टाइम फ्रीक्वेंसी इसकी डाउन हो गई। तो ये एएलएफसी का रोल हो गया। बट दिस इज नॉट अलाउड। इसने फ्रीक्वेंसी सेंस किया कि भाई अब तो 48 है, इसके अकॉर्डिंगली यहाँ हमारा एक इंटीग्रेटर लगा हुआ है, एरिया कंट्रोल एरर और इंटीग्रेटर लगा हुआ है। इसने फिर एक सिग्नल दिया कि भाई अपनी पावर और बढ़ाओ, स्पीड चेंजर सेटिंग के थ्रू इसने इससे कहा अपनी पावर और बढ़ाओ। तो फाइनली ये स्पीड गवर्नर से होता हुआ और इधर से होता हुआ एम्पलीफायर, बिकॉज द सिग्नल इज वीक सो एम्पलीफायर इज नीडेड हियर, अगेन इट इज सेइंग इंक्रीज द पावर। इसने फिर फ्यूल 110 से भी थोड़ा ज्यादा फ्यूल बढ़ाया, सो दैट इसमें जो एनर्जी स्टोर थी जो कम हो गई थी वो स्टोर एनर्जी इसको बढ़ा देगा और जब बढ़ा देगा तो इनपुट इक्वल टू आउटपुट के साथ साथ इसकी फ्रीक्वेंसी को भी 50 हर्ट्ज मेंटेन कर पाएगा। तो ये हो गया प्राइमरी ऑटोमेटिक, ये सॉरी दिस इज कॉल्ड द सेकेंडरी ऑटोमेटिक लोड फ्रीक्वेंसी कंट्रोल। ये हमारा सेकेंडरी ऑटोमेटिक लोड फ्रीक्वेंसी कंट्रोल हो गया। और ये प्राइमरी, ये सेकेंडरी, टोटल इज कॉल्ड द ऑटोमेटिक लोड फ्रीक्वेंसी कंट्रोल। ये हमारे फ्रीक्वेंसी को कंट्रोल कर रहा है। ओके, तो दिस इज ए ऑटोमेटिक लोड फ्रीक्वेंसी कंट्रोल लूप एंड दिस इज द एक्साइटेशन कंट्रोल और वोल्टेज कंट्रोल लूप। यार यू सी, शॉर्ट में इसे भी बताऊंगा कि भाई इसने वोल्टेज, सपोज आपका लोड ऐसा है कि रिएक्टिव पावर की बात हो रही थी, रिएक्टिव पावर डिमांड इज हाई, तो ये सेंस करेगा रिएक्टिव पावर डिमांड इज हाई एनीवे, तो किसी कारण से भी अगर इसका वोल्टेज डाउन हुआ, ये वोल्टेज पोटेंशियल ट्रांसफार्मर विल सेंस द वोल्टेज, कन्वर्ट इनटू डीसी सिग्नल, कंपेयर विद द डीसी, मींस अगर ये सपोज करिए 1 पर यूनिट होना चाहिए और इसने कंपैरिजन 1 पर यूनिट से किया, ये 0.9 आ रहा है, उसके अकॉर्डिंगली एम्पलीफायर एक सिग्नल देगा और एक्साइटर को कहेगा आप अपनी फील्ड करंट बढ़ा दें, तो ये फील्ड करंट बढ़ा देगा। फील्ड करंट मींस इफ इट इज ओवर एक्साइटेड, ये आपको फिर बताऊंगा, इफ इट इज ओवर एक्साइटेड then it will supply more reactive power. If it is under excited, it will supply the less reactive power or leading power. So by making this over excited or under excitation from here, we can control the reactive power and then this voltage. So this voltage is controlled by this loop called the AVR control loop. The frequency is controlled by this loop, which is called the automatic load frequency control loop. This is one complete chapter that we will describe, that we will study here, and this is another one complete chapter that we will study after completing this chapter. Okay, so there are two separate studies that will be studied here, and to understand this, it is not sufficient to learn this two schematic diagram. To explain this schematic diagram is not sufficient for you. We have to understand each and every part of this. That what is this turbine, what is the model of this turbine, how it behaves, what is the equations, and how much it changes because of this, what is the effect on each, इसमें आपका hydraulic amplifier में कितना effect आएगा इसमें. So we have to develop the model of each and every component of this loop. We will model the each and every component of this loop, then the interrelation between them, and we will study in detail. We will make all the analysis which you have studied, steady state analysis, dynamic analysis, transient analysis, all those analysis will be performed. Okay, so if you have any query up to now, you can ask. If you don't have the query, because today we have the invigilation duty at 9 o'clock, so we can discontinue from here, and if you have the query, we can respond also. So